In this video, we are going to be learning how to factor trinomials in which the leading coefficient, the coefficient in front of this term right here, the x squared term, is not 1. And it is also not a GCF, so 2 does not divide into all terms. So when you have a leading coefficient that is not 1, we are going to first learn today what's called the guess and check method. There's many different methods you'll find online. I'll teach 2 of them in my lessons, but today I'm just going to do the guess and check, and it's one of the most important ones because it's something you can always fall back to if the other methods are not working or the numbers are really big. Basically, the guess and check just means try to figure out what numbers to put in your 2 binomials such that when they FOIL out, you get back to the beginning. So by guessing and checking, I first guess the first and the last. 2 numbers that multiply to give 2x squared are 2x and x, and you just plug them in. 2 numbers that multiply to give 3, which is the last, are 1 and 3. You just plug them in. You don't know which order. It's now where you have to check. So the guessing is the first and the last. The checking is that the outer and the inner add to the middle term, to 7x. So when I plugged the 3 in and the 1 in, I get a 2x for my outer and a 3x for my inner, which is 5x. That didn't work. So my first guess was wrong. So then I just fix it up. And the 2x and the x I left there, but I switched the order of the 1 and 3. So now my outer product is 6x and my inner product is 1x, which does give me 7x. Therefore, this is my final answer. And again, 2x plus 1, x plus 3 can be written in either order. When I do this, instead of rewriting it every time like this is how I typically guess and check. For the 2x squared, I would write the 2x and the x. For the 3, I would just write the 3 and the 1 in either order. Then my outer and the inner are my diagonals. That gives me 3x, that gives me 2x. Nope, that was wrong. So then I would just go, nope, 1 and 3. That gives me 1x, that gives me 5x. Oh yes, that gets me to, 6x. That gets me to 7x. And so the 2x plus 1 becomes the first term, and the x plus 3 becomes the second binomial. And so that's how I typically write it in my guessing and checking. It gets messy, but that's all you need to do. So let's try that. So 5x squared, I'm going to guess 5x and x. That's my only option. Prime numbers are the easiest with guessing and checking because there's not a lot of options. With the 6, I have lots of options. Well, I have 2 options. I have 1 and 6, and I have 2 and 3. And again, just like last lesson with the factoring, if this is a positive, we know that it's positive 1, positive 6, or negative 1, negative 6. Same thing with the 2 and 3, both positive or both negative. Then I look over here to the positive 17. Since it's positive, I know that everything's positive. You don't have any negatives because you're not going to add negatives and get to a positive. So those signs tell me a lot. So 1 and 6, I just throw them in. 1 and 6, I get 31. That doesn't work, so I switch the order. I get 5 and 6 is 11. That didn't work, so I go to the 2 and the 3. I get 15 and 2. Oh, 15 and 2 is 17. So I now know my first factor is 5x plus 2 and x plus 3. And that's all you do. So if I was to FOIL this out, 5x squared plus 15x plus 2x plus 6 and collect like terms, I'd get back there. Let's try another one. This time it's the 5 that's prime and the 4 that isn't. So I start with the 5 and break it into 5 and 1. And now I fiddle with either 1 and 4 or 2 and 2. I usually start with the closer together ones first, the 2 and 2. So let's go with the 2x and 2x and see what I get. I get 2x and 10x, which gives me 12x. Oh, again, since that's positive, they're either both positive or they're both negative. But since that's negative, I know they're both negative. So I would put negatives there, right? So negative 2x and negative 10x is negative 12x. Hey, I guessed it right off the bat. So my first factor is 2x minus 5. My second factor is 2x minus 1. And the FOILing is always the diagonals. When I'm checking, I'm just checking that the diagonals get me to that. Let's try another. Again, they're both prime, so it's not too bad. The y squared just becomes y and y. The 3x squared becomes 3x and x, and I just plug them in wherever. And I get, just check, here I get 3xy, xy. When I add them together, I get 4xy. And again, positive y squared adds to a positive, everything's positive. So my factors are 3x plus y, x plus y. Let's go over here, 2x squared. 2x and x. This time, we now have a negative in front of the 3. So reminder, when you have a negative in front of the 3, you have one of them positive and one of them negative. I don't know which one. So you, again, just guess and check. But here's another tip. When the sum is negative, when the outer plus the inner gets you to the negative, you know the bigger product is negative. So I usually just, wherever I put my two numbers, I put 3 and 1 down. That gets me 2x. That gets me 3x. The bigger product is oh, that would add to negative 1x. That's not negative 1x, so let's switch the order. This time I would get 6x, x, and the bigger product is negative. Oh, that gets me negative 5x. So I want the 6x to be negative, so I need my 3 to be negative. And I want my 1x to be positive, so the 1 needs to be positive. So I get 2x plus 1, x minus 3. We'll do a few more. You're just guessing and checking. You don't have to do this method. You can actually just fill them in right there. Put the 2x and the x there, and then just put 1 and 3 and just keep checking outer and inner. Do we get that with the outer and the inner? I just do this just because it speeds up the process for me, but it's your choice. Practice whichever way you want. Factoring is something, there's lots of ways. You just pick one way or a couple ways and you get really good at them and you work on your speed. So 3x squared becomes 3x and x, and I have options 1 and 4, 2 and 2. Let's try the 2 and 2 first. Again, since it's negative, they're opposite signs. So the bigger product will be negative since that's negative, so that's 6x. So I'm getting negative 6x, and I get 2x. That's not going to get me negative 1. So the 2 and 2 are not going to work. So I'm just going to get rid of the 2 and 2, and I'm going to go to the 1 and 4. That one's gone. So again, you can start getting smart. If I put a 4 here, I can see I'm getting 12x. I'm not going to get a negative 1 with that. So I'm going to be smart about it. I'm going to put the 1 there and the 4 up there. Because there I'm going to get 3x. This diagonal I'm going to get 4x. The bigger product is negative. That gets me to negative 1. So I want the 4x to be negative, so I have to put the negative in front of the 4. And I want the 3x diagonal to be positive, so I put a positive there. And I get 3x minus 4 and x plus 1. Maybe we can do that. The guess and check is nice because I can give you all these different forms. And it's handy, the y squareds don't mess you up or anything like that because you just split it up. 5x and x, 2y and y. Let's be smart about it. I need 9. So I can see that if I put the 2 across from the 5 diagonal, I can get a 10. And if I put the 1y across from the x, I can get a 1, right? And my kind of way of thinking is if this is negative, my diagonal products differ by 9. If this was positive, my diagonal products add to 9. So I kind of just don't even worry about the negatives yet. I just throw them in at the end. So I get 10y and y. 10 minus 1 is 9. Good. But I want positive 9, so I want the 10 to be positive, and I want the 1 to be negative. And we can get cleaner and faster at this without having to write so much just by doing a little thinking. But at times you think, you mess up, that's why it's called guess and check. Is at times you're going to have to do it a few times to get to the right answer. Same thing here. The 1 is prime, so I split that up first. 9, it could be 1 and 9 or 3 and 3. It's easy to eliminate the 3 and 3 first if it's not correct because there's only one way order to put it. So I put the 3x and 3x. Since it's positive, my diagonals add to 6. 3x and 3x is 6x. Well, that works. And since it's negative 6, they're both negative. Remember, if that last term is positive, it's either both negative or both positive. Since they're both the same, rather than writing 3x minus 1 and 3x minus 1, I'm just going to write 3x minus 1 squared. Over here, I have 2x squared, which is prime, so I'm going to write the 2x and the x, and I have 1 and 10 or 2 and 5. I always start with the smaller ones first, and if that number in the middle is really big, I would start with those ones. If the number in the middle is small, I would start with the closer together. And again, since this is negative, again, the opposite order makes this method pretty easy because you can just keep the order like it is. And since that's negative, my diagonals differ by 1. And the leading coefficient there is 1. So they differ by 1. So I'm going to put a 2 here because I can see that makes it 4. I'm going to put a 5 here because that makes it 5. 4 and 5 differ by 1. And since it's negative, I want the 5 product to be negative, and I want the 4 product to be positive. So I'm going to get 5 plus 2x, which if you want to rearrange the order, you absolutely can, to put it in descending order. And I probably would not switch this order because when it's subtraction, I always like the leading coefficient, the 2, to be positive. I would probably leave it like that. The last thing we're going to talk about is what happens if I give you a trinomial and we're missing this term here, this middle term k. What are all of the possibilities? Is there only one possibility, 2 possibilities, infinite possibilities for k? Well, k is your outer plus your inner in the FOIL. So if you have x squared, you know it's going to be x and x. If you have 8, you have a whole bunch of options. You have 1 and 8, or you have 2 and 4. Those are your options. You also have negative 1 and negative 8, and you have negative 2 and negative 4. So you have 4 different options to go in here. If you put 1 and 8 in here, the outer would be 8x plus 1x, which would be 9x. So k could be 9. If you had a 2 and 4 in here, your outer would be 4, your inner would be 2, you would have 6x, or k could be 6. Or what happens if I change them to negative? Oh, I get negative 6x, so k could also be negative 6. Oh, same thing up here then. If I had negative 1 and negative 8, we could get negative 9. So k could be, and instead of writing 6 comma negative 6, I could write plus or minus 6, and k could be plus or minus 9. So there's 4 options for k to make this a factorable trinomial. That means any other number for k, it's not factorable. Those are the only ones that k can be as integer values to make this factorable. Let's try this one in which my leading coefficient is 2. So this could be 2x and x. That's your only option. So let's split it up into 2x and x. This time I can't just think 1 and 5, etc. Well, yeah, I can think just 1 and 5. That's the only option, right? So this time order matters since these terms aren't the same. The order didn't matter here because of the first terms were the same. But now that the first terms are different, order does matter. So if I put a 1 there and a 5 there, and since it's negative, I'd have to put a negative 1 and a positive 5. My outer plus my inner would give me 10x minus 1x, which is 9x. So in this case, k is 9. Or, what if I did it this way, though? Then I would get negative 10x and 1x. I would also get negative 9x. So in other words, k could also be negative 9. What if I switch the order? What if I put the 5 here and the 1 here? Make them positive and negative. I would get negative 2x and 5x. I would get k equaling 3x. So k could be 3. And again, switch the order. Oh, k is negative 3. So you just have to put in all of the options. If there was another option there, there'd be 4 more options for k, right? K could be plus or minus 3 or plus or minus 9. You just have to go through all of those options to make that factorable. So this is using your guess and check method. I will be teaching an AC method in the next lesson. But this one's always a good one to get really good at and practice because when the numbers get really big, this is a good one to fall back on because the AC method could get tricky for some types or when the order changes, etc. Or when you have to guess k, this is based on the guess and check method.